Some developers are pulling Linux support to prevent cheating, but banning an entire operating system to stop cheaters, that's not just lazy, it's technically flawed. Let's break down why Linux isn't the problem. So let's start with the facts. According to StatCounter, Windows holds about 70% of global desktop market share. Linux, just under 5%. And on Steam, Linux users make up only 2.6% according to the Steam hardware survey. So banning Linux affects a tiny portion of players and does almost nothing to stop cheating at scale. Still, Linux gaming is growing. According to The Verge, Valve's Steam Deck has sold between 3.7 and 4 million units in just 3 years. Combined with other handhelds like the ANA, however you call that, and the Legion Go, over 6 million Linux-powered gaming devices are in players' hands, according to TechSpot. This isn't niche anymore, it's a growing platform that developers should support, not block. So let's talk about how cheating actually works. Cheating methods themselves are usually OS-agnostic, but the tools developers use to detect them, those definitely depend on the OS. Most cheats fall into a few buckets: memory modification, DLL or shared library injection, packet spoofing, macro tools or hardware automation. All of these work on any OS, whether it's Windows, Linux or Mac OS. But here's the real difference. On Windows, kernel-level anti-cheats like Vanguard or BattleEye run with full system access. They can scan memory, monitor drivers and detect system-level tampering. On Linux, that approach just doesn't fly. Linux is built around transparency and user control. Running a closed-sourced anti-cheat driver in a kernel? That's a non-starter for most users, and for good reason. So yes, cheating works the same everywhere, but developers block Linux not because it's unsafe, but because it pushes back against surveillance-style anti-cheat models. And let's go deeper. Some of the most powerful anti-cheats don't even rely on the OS at all. DMA or direct memory access lets PCIe or USB devices read game memory directly. These devices bypass the operating system completely. Anti-cheat tools can sometimes detect the devices, but many spoof legitimate hardware to hide entirely. Then there's virtualization-based cheating. In 2024, a paper on Arxiv introduced VIC, a cheat that runs from outside the game's OS using a stealth hypervisor. Even kernel-level anti-cheat can't detect it because it's not in the system it's monitoring. Standard VMs like VirtualBox can sometimes be detected, but custom hypervisor, they're built to stay hidden. And again, these can work on any OS. Some devs argue that Linux is too open, that it gives the users too much control. But that same openness also means transparency, auditability, and innovation. Let's not forget, kernel-level cheats and rootkits exist on Windows too. Being closed doesn't mean being secure. The real problem is this: Linux doesn't allow the same deep access that anti-cheat vendors expect from Windows, and instead of adapting, some just block the platform entirely. Let's look at the big picture. Here's how common cheats stack up. Memory injection, OS agnostic. Packet spoofing, OS agnostic. DMA cheats, OS agnostic. Hypervisor based cheats, OS agnostic. Cheaters target the game, not the OS. Blocking Linux doesn't fix cheating. It punishes the player who value control, security and freedom. So cheating is a real problem, and it's evolving. But the operating system isn't the threat. The real issue is how developers choose to build or ignore smarter anti-cheat systems. Blocking Linux isn't protecting players. It's gatekeeping a growing part of the gaming community. So yeah, Linux isn't the problem, and it never was. If you want to stop cheaters, build smarter systems, not smaller communities. If this video helped you see things differently, then hit that like button or drop a comment, and subscribe for more videos on my Linux journey, from gaming to content creation and everything in between. I'm Mo, thanks for watching, and I'll catch you in the next one.